All right, let's get started, everybody. So welcome back. As always, I am taking questions in the chat, and I'll also take questions on the forum, so I'll keep an eye on that as well. Today's lesson is about functions. So up until this point in the class, what we've been doing is we've been writing, if we go back and look at the algorithms example from yesterday, right? We've been writing what's known as loose code, and here's how that looks. So in loose code, we're, the code that we write, we expect, Java to execute from sort of top to bottom. And, we're kind of declaring variables, we're operating on them, and we can use all of the basic programming constructs that we've learned so far. But one of the things that's going to concern us for the rest of the semester is how do we structure our programs? And actually that's a big part of both today's topic and then something that we'll get to later when we start to talk about objects. And structuring, so right now you might think writing these small programs, this isn't that important, but finding ways and learning ways of structuring your code becomes increasingly important and is really impossible to avoid once you do anything that is actually real, right? If you're going to write a real program to solve a real problem, you're going to end up with enough code that you're going to have to start to think about structure. You're going to have to start to think about reuse, how to make parts of your code more easy to reuse in other places, right? If you have one bit of code that does a useful thing, you don't want to have to keep repeating that piece of code everywhere that you need to perform that task. So today we're going to talk about how we can bundle up a chunk of code into something that's called a function. Functions are, function is a word that computer science shares with several other domains, including mathematics. And, the mathematical notion of a function has some relevance here in the sense that, it takes, to be honest, it's been so long since I studied math, I'm trying to even remember what a mathematical function is. It takes some inputs, produces an output. That's not, entirely alien to the computer science notion of a function, right? Where we also provide it with some inputs, we're going to receive some output. But we're going to really focus on this as a computer science idea, right? Where what's inside a function is code. And the idea is that by defining and declaring a function, I can then reuse the code that's inside that function wherever I need to perform a specific task. And so, we're already starting to kind of go in the direction of, if you look up, the Wikipedia definition of function, what exactly a function is, right? So the idea behind a function is I take some code that performs a task. Sometimes that code implements an algorithm. Sometimes that code might implement several different algorithms in order to perform a task, right? But this code does something useful. It has to, typically when we write a function, we're thinking of code that's going to perform, some task, and, not always, but frequently the function is going to be used in multiple places in our code. Again, that's not always true, but it's frequently true when we write a function that we're kind of thinking about, okay, this is the kind of general purpose, problem that I might need to solve multiple times, or need to have, this problem solved multiple times at different places in my code. And so rather than repeating myself by just cutting and pasting the code over and over again, I'm going to define a function to do that. So, skipping ahead a little bit, so this is sort of the rationale behind functions, and again, I encourage you to go through the walkthroughs that are included in the lesson. So let's just, in the lesson I go through kind of how to convert the loose code implementation of the search algorithm that we talked about yesterday when we introduced algorithms into a function. But for this, for our session, why don't we just start by squinting at a function together, at a function definition, and kind of trying to pick out the different parts. And we'll do this the way that we always do, which is that, we look at things that are new and we try to identify things that we understand and figure out the parts that we need to learn about, right? So, which part of this looks familiar, which part of this looks strange. So I'm just looking at the code that's at the top of the lesson, a little example here. If we run this, you'll see that it prints two values. But it's the code up here. So this down here is somewhat familiar to us, right? I see the declaration of a variable of type that's going to store an array of ints, and the initialization of that variable over here on the right. And then up here, down here, I see a couple of calls to system.out.println, which we know is going to display something to the console so that we can get a sense of what's happening as the program runs. But this stuff up here, this is the part that's a little bit unfamiliar. Now again, let's, piece together the parts that look familiar and what doesn't look familiar. So there's a block of code over here. And we've seen this before. We've seen this syntax. We've seen open curly brace, close curly brace. The code inside of it is indented, and what's inside of it is code. A lot of the code in here should look familiar to us, right? Line 2 is the declaration of a for loop. That loop opens up its own block, right? And so we see that the code inside here is indented even a little bit more. The for loop, this is our canonical for loop definition that's going through an array. We see that the for loop is using something called values that seems to be an array of integers. I'm accessing its length using this length property, dot length. And it also seems to be using this variable called looking for that seems to store an int, because I'm comparing on the left side of my equality operator the value in values at that particular position I, which is an int, against something. And so whenever I use the equality operator, I know that the two things on each side have to be comparable to each other. And in this case, they have to be the same type. So if the thing on the left is an int, then the thing on the right has to be an int too. Okay, so, and again, I'm just focusing on this block. This is new. This statement, so we haven't seen return before. This is a new piece of Java syntax that we're going to have to understand together. We'll talk about that in a minute. Right, so that's new. And then, of course, pretty much the entirety of line 1 is also new. And let's break this down piece by piece. So first of all, let's look in here. So I've got an open and closed parentheses. And inside of that, so I've seen open and closed parentheses like I see them here in my for loop, right? I've seen them used here before. I saw it in my if statement. I can see one here as well. But the contents of these parentheses are a little different than what we've seen before. And this is one of the things that can make, I think getting used to the syntax of a programming language sometimes a little tricky, because the same symbol, in this case parentheses, is used in a couple of different ways, right? Even within the same program. So here it contains a conditional expression because it's the second part of an if statement. When it follows a for declaration, it contains the three parts of a for loop declaration. The part that only gets executed once, where I'm declaring my loop index variable, the part that gets the conditional expression that gets checked every time before I enter the loop that determines when the loop stops, and the update statement that gets run every time I go back to the top of the loop. In this case, I'm incrementing I so that I go one step at a time through my array. But up here, you'll see that, what's inside of these parentheses doesn't look like a conditional expression, and it also doesn't look like the for loop contents that we've seen before. So this is a little different. What we see in here instead is, again, and we're approaching this as if we, like we haven't seen this before, because we haven't, right? And so we're just trying to identify things that look familiar, right? So this looks familiar. This looks like a variable declaration. When we declared and initialized a variable before, we would do something like this, and we would typically put something on the right side of an assignment so the variable had an initial value. But there's really two parts of this, right? There's the variable declaration, where you tell Java, I'm going to use a variable called looking for, and the type is int. And over on the right side of the assignment, I tell Java what the initial value is. That's the initialization. So inside the parentheses that follow this function definition, I see what looks like two parameter or two things that look like variable declarations. This one looks like the declaration of a variable that would store an array of ints, right? Because I have int and then I have the open close brackets, which indicates that this is an array of ints. And the name is values. And then I see a comma, and then over here I see another variable declaration, right? So I see two of these separated by commas, okay? So again, what's in there looks somewhat familiar, but it's being mashed up in a new way. All right, so we're kind of going backwards here through the function definition, which I think is actually probably the best way to do it. So we saw that there was a block of code within the curly braces. We've identified that there are parentheses, and inside those parentheses, it seems like there are things that look like variable declarations. Now I just see, a string of characters, right? And this is a name, right? I wouldn't expect you to know that, but this is like a variable name. This is up to us to choose. We can call this function whatever we want. Just like you're allowed to name variables in Java, when you define a function or declare a function, you're also allowed to name that function. Now, one thing I want you to be careful of is that when we do homework problems in this class, we are going to tell you the name of the function to use. So unfortunately, we don't give you permission to use any old function name when you create your functions as part of the homework. And if you don't use the name that we gave you, things will tend not to work, right? And I can show you that in a minute, right? If we want to at least, so, well, why don't we just look at it ourselves? So go down and we'll do the, look at today's homework problem. Let's say that I say, okay, I'm going to say, I'm going to try to define, I'm going to declare a function called add1. So let's say it's int add it, and it's going to take a single int argument. Now the arguments you can name, that's up to you. And let's say I return to add +1, and I think, okay, you asked me to add 1, I'm adding 1, does this work? And you're going to see that when we tested your code, it did not work. And the reason it didn't work was because we asked you to declare a function called add1, and you created a function called addIt. Now your function is correct, it does what we asked you to do, but part of the problem specification is also following the instructions about how to name things so that we can test your code properly. Okay, back to the top. So now we have this name, so that's the kind of the third part of the function we've talked about. We saw that there was a block of code, we saw some things that look like variable declarations inside parentheses, we see a name, and then the last part, and going backwards, right to left, is a type. And what we see here is the name of a type, and it's one of those 8 primitive types that we've talked about in the past. Boolean, int, long, char, double, float, byte, and short. And again, this is new, right, in terms of it appearing here. But on some level, if you think about it, this part of this looks a little bit like the variable declarations we had seen before. But instead of declaring a variable, when I declare a function, I'm providing all of this extra information. All right, so what's actually going on here, right? So now that we've kind of squinted our way through the function declaration, let's try to figure this out. And again, for fun, as part of this, as part of my walkthrough, let's just try to do this sort of inductively, right? Rather than me explaining it to you, which I do later in the lesson in some of the walkthroughs, let's just experiment and see if we can figure out what's going on. Okay, so I see that when this code runs, it's printing off two Boolean values. And if I look at this piece of code and try to figure where do I see Boolean values? Well, I see a Boolean value here and I see a Boolean value here. Okay? And so maybe those are connected to the fact that when I run this code, and I also see the name of this function. So I see this name twice. I see the name up here, and then I also see it down here. Okay, and so this is sort of interesting. So why don't I put some print statements? So my first hypothesis is that this function is being run. Somehow this code is being executed. I don't really understand how yet, but let's check that out. And when I put a print statement here on line 2, what I see is that I see that printed twice. Okay, so that's interesting. I only see this function declared once, but here is being printed twice, and I also see it printed before the other print statement, right? And let's put some other print statements in our code. This is always kind of a fun way to mess around with your program and try to get a sense of how it's working, right? So I'll put another one down here. Okay, so now I can see the first thing that's printed when this program runs is start. Then this print statement on line 2 is executed, which is interesting. Then I see true printed, and the only place I see true in this program is here. So that's interesting. Now again, I can print true in other ways. So for example, if I print something like this, that's also going to print true, right? So I don't have to see a literal true for the value true to be printed. I can print the result of a conditional expression, and Java will print what it evaluates to. But again, it's just sort of a clue for us that we see these literals as part of this function definition, and we see them attached to this return statement that we don't yet really understand. Okay, but it's clear now that this function is being executed somehow, and we can also see from the order in which this is happening. Let's put another thing in here. And we'll put a print statement between these two other print statements. So now I'm printing start, and I see that printed first. Here is printed next. Then true is printed, and I'm going to hypothesize that true is printed by this print statement. Now I see middle, right? So now I'm on line 13 clearly, because that's the only place in the program I print middle. Now I see here again. So somehow I've returned to line 2. Then I see the value false, and then end. Okay? So now my hypothesis is going to start to be somehow this name, when I use this name and I put some stuff in parentheses, what's happening is that it's causing the code in this function to be executed. And now one of the interesting questions is, the code that's inside this function is using a variable called values as if it has a value, right? As if there's something in that array. It's also using this variable looking for on the right side of an assignment as if it has a value. And so the question is, the next thing we're trying to figure out is what value do those variables have and why, right? Where did that value come from? If they have a value, can we figure out why they have that value? So let's print off the value of looking for. Okay, so, and I don't know if this is going to work or not. Maybe I can't access looking for here. I'm not sure, but I'm just going to try it, right? See what happens. Okay, run this again. All right, so now I see 2 more print statements in the output, right? I see one that prints 2 and the other that prints 4. And again, this is interesting because if I look inside the function, right, I see something that looks like a variable declaration up here. But I don't see a value anywhere, right? Like, where did looking for get assigned a value? Why does it already have a value on line 3? There's no, thing that says looking for is equal to 2 or whatever. I don't see that statement anywhere. I don't see an assignment to looking for. So that's weird because looking for has a value. It has the value 2. So the question is, how did that assignment happen? So let's look through the rest of my code and try to figure out, like, where did these values 2 and 4 come from? Where do I see them, right? So I see one here on, as this, suspiciously, it seems to be connected somehow to this name of the function search array, right? So I see this name 2 places. And now, here's what's interesting. So up here, I see what looks like 2 variable declarations of a variable named values that's an int array and of a variable named looking for that's a single int. And down here, again, between parentheses, I see 2 values, okay? This is a literal value 2 that's of type int. This, okay, so where does this come from? Well, this was declared right here. This is a variable called example that stores an array of ints. And so what I can see is there's this match between this, the type, not the name, don't let the name throw you off, the type of this and the type of this variable, and the type of this variable and the type of this variable. This is an integer literal, and this value accepts an int. And so it's almost as if, and again, this is not valid Java code. It's almost as if what happened is I did something like this. I'm going to use example. It's almost as if this is what happened when I ran the code that time, right? I had an assignment that occurred, but there, instead of there being an assignment operator, somehow the assignment got split into 2 parts. There's the declaration of the variable up here, and then there's the value that gets assigned to it here. Okay, so that's interesting. So let's now the other thing that's a little strange is when I run this again, I see the value 4. And so what I'm starting to realize is that the value in looking for can change each time the function runs. It's not the same. And what I'm noticing is that it's the caller of the function. So when I use a function, I get to provide a value for looking for. So when I use the search array function, we call this calling the function, I get to provide a value for values. That's an array of integers. So essentially, I get to tell the search function, I'd like you to look through this array of integers. I also get to tell it what to look for, right? So I get to say, look for this value in the array. Okay, so again, sort of trying to approach this as purely inductively as possible. Please, stop me with questions if you have them, right? This is, not necessarily. I'm doing my best here, but this is hard for me, right? Because I've understood this for so long. So sort of like building it up incrementally is a little bit of a challenge, and I'm probably skipping some steps here that might confuse people. So if you're a little confused about what's going on, jump up and down, and we'll talk about it. Okay, so now unfortunately we don't have a good way of printing arrays yet, but if we want to, we can investigate what's in values too, and we can do that by kind of just printing the different elements of it. So it looks like values is an array that has first element 1, second element 2, third element 5, and doesn't have a fourth element, right? Because now I get this error message that I've seen before that tells me, hey, this array doesn't have a fourth element. So again, what I've noticed here, and now I've sort of explored the values of both of these variables. So I've noticed that what's contained in values seems to be the same contents as the array example that appears when I reference this function it appears between parentheses as the first thing, right? And this I reuse both times. Now for fun, let's use a different int array. So let's use something that contains like 0 to 4. Oh, it doesn't like this. Yeah, we got to do this. Okay, so now if I print the value of value 0, I'll see that the first time I call, or the first time the code up here runs, the first item in this array has the value 1. The second time it runs, it has the value 0. So it seems like, just like I did with looking for, I'm allowed to change the contents of this array each time I call the function. Okay, so now we have some sense of what's going on and what's stored in those variables. And now, on some level, the code in here is just going to run, right? So if I imagine that value stores whatever's in the array that is provided when the function is used as the first thing in between parentheses, separated by commas. And then looking for is an int that is the second thing in this list that's separated by commas in between the parentheses. Now I can, most of this I understand. So I'm going through the entire array with my canonical for loop. If any of the array values is equal to looking for. Now this is, again, something that's new. So let's try to figure out what this does. Okay, so what I can do here is I can let's print off the index that I'm at as I go through the array looking for the value, right? Okay, and for now, let's just comment out the bottom part of this. We'll just look at one call. It's starting to generate more output. Okay. So, and also let's before we even get in here, let's print the value of the length of values. Okay, so the length of values is 3. That makes sense to us maybe because example refers to this array that has 3 integer values in it. So that's great. That lines up with what we expect. Now what's interesting here is I see 0 printed and I see 1 printed, but I never see 2 printed. Okay, so somehow I didn't get through this entire array. Previously, when we work with arrays, we've seen how to use break to stop a loop from executing. And so one thing we might think, and what's suspicious about this, right, is that the value we're looking for is at position 1. So clearly something happened when we went through the loop the second time and I was equal to 1 that stopped the loop from continuing to execute because I never saw it print I is equal to 2. Now let's look for a different value. In this case, if I look for 3, I see I is equal to 2 printed, okay? And what's the difference between these two values? Well, the difference is that 2 is in the array, and it's also the item at the first index or at the second position. And so clearly what's happening here, and I can actually convince myself of this, right? So let's print values I is equal to looking for, because that's the condition I'm about to check. So clearly there's something connected to entering this if statement that causes the loop to stop executing. So again, maybe this is like a break. Maybe what happens is the loop just jumps down to, I just jump out of the loop, okay? So let's put another print statement, and we'll call this bottom, and we'll say this is at the bottom of the loop. Okay, so this is really interesting. I'd never see bottom printed. All right, well, let's try a different value again. Let's try something that's not in the array. Now I do see bottom printed. Okay. And what else is changing about this? The thing that's being printed is changing. Okay. All right. So again, let's try a different value, and let's use 1. Now I see, and I'll get rid of the values.length, so this doesn't confuse us. So now I only see 0, and I see the value true if I use a value that's not in the array. So if I use a value that's in the array, I see that the loop stops executing as soon as I find that value, and I never get out of the loop. I never get to line 8. Interesting. If I had a break statement, I would get to line 8, right? Because I would break out, and then I would be at the bottom of the loop, and I would keep going. So there's something different about this return statement from the break statements that we're used to, but somehow it is stopping the loop from continuing to execute. So if I use something that's not in the array, I see all of the indices of the array printed. I see false printed by this print statement. And I also see that I got to line 8. And so what I can start to hypothesize is that return doesn't just stop the loop, it also stops the entire function. So when I get to a return statement, the entire function that I'm executing stops. As soon as I reach return, the whole thing stops. If I put, let's try this. If I put return false, now checkstyle is going to get mad at me about this. So let's comment this out. But I could write this code, right? Now you'll see that I see start and I see false, and because this code is commented out, that's the reason that we're not getting here. But I could put this code back in, and the result would be the same. So somehow, as soon as my function reaches a return statement, the rest of the function is not getting run at all. So let's do this in a different way. Let's say if values.length is greater than 0, return false. Okay. So now you'll see, and again, if I run this, so now what you'll see is interesting is that I don't even see this printed, right? Let's put a print statement here. Nothing. So in this particular execution of the program, I'm not even getting to line 5 when I call this function. And let's put this print statement here, and I'll say returning, kind of to indicate the point in the program where I think and there we go. So somehow when I get to this return statement, the whole function is exiting. And that is exactly what happens when we use return. Return causes the function that it is enclosed in. And it doesn't matter how, you can have return inside 4 nested if statements, and it doesn't matter. It immediately causes the function to stop executing. So when you see return, you're done. The function will not continue to execute other pieces of code. And so right now, the reason I don't see anything else printed is because I'm passing in an array that has a length that's greater than 0. This is kind of how I fool checkstyle to allow me to do this, right? So I've got some sense of return, and now there's like one more piece of the puzzle that I need to bring in, and that's this value, okay? So return, I see a return statement, and then on the right side, I see a value. This is a Boolean literal, right? True and false. I see both of them used in this function. False is used here, true is used here. Okay, so that's interesting. The other thing that's interesting is let's put a print statement here we'll say returning true, and down here I'll replace this with returning false. And now what we're going to notice, get rid of this guy, is that when I search for a value that's in the array, I see returning true, and then I also see that this print statement also prints true. When I look for a value that's not in the array, I see returning false, and that this print statement always returns false. So there seems to be some connection between, the argument, and it's not an argument really, but that what follows the return statement, and the result of calling the function. Because when I call print, I'm essentially going to execute the function, and then I'm going to print whatever the function evaluates to. What's the result? What is yielded by this function, right? The other thing I'll point out is that there seems to be, so let's try returning something else, right? Let's say that, let's return 1 and 0 here. So we'll try returning a different type of thing. We'll try returning an int instead of a Boolean. And now I see that I have a problem. This code is not correct. Java's going to complain about this. Why? It's telling me that int cannot be converted to Boolean. So somehow it seems like Java expects, so there, at this point, there's one of two things is true, right? Either the only thing I can ever return is true and false, or somehow Java is under the impression that this function should return a Boolean. And so let's go back to our function definition and look at the first part of it. Aha, okay, this is interesting. So maybe the problem here is that I told Java that the function would return a Boolean, meaning that, if you call this function, you should expect to get either true or false back. And then the problem that Java is pointing out to me is that when I return, I'm actually returning an int, and Java can't convert an int into a Boolean. So let's test that hypothesis. And the way that we'll do that is we'll change this return type for our function into an int. And now we'll see what happens. Okay, interesting. And of course, this is wrong. This says returning 0, and this should be returning 1. So now I'll see that the value returned, that when I call this function, the result is now an int. And so it's okay to return an int from a function, just like it's okay to return a Boolean. But what you have to do is when you return, the value that you return has to agree with the declaration of your function. So if I declare to Java that my function returns an int, and then I return a Boolean, it's not going to like that. If I declare that my function returns a Boolean and then I return an int, it's not going to like that either. Now in this particular case, it's more appropriate for our function to return a Boolean because we're returning whether or not we found the value in the array or not. So the question I'm asking, or the task that this function is performing, is does the value contain this array or not? Or does the array contain this value or not, right? And that's a true or false question. It's either in there or it's not, right? If it's in there, I'll return true to indicate that I found it. If it's not, I'll return false to indicate that I didn't find it. Let's see here. So where did my form thing go? Yeah. Hope you guys are all good. Thanks for the hello. Again, happy to take questions. So at this point, just through kind of trial and error and experimentation, we're basically there. Like, we've covered today's lesson content. We did it very differently than I do it in the walkthroughs, but we sort of worked backwards, right? We kind of said, okay, let's mess around with this function and see if we can figure out how it works. Let's try a couple other things, right? So right now I'm printing the result of calling this function. I'm starting to use the terms that we use. What else can I do with this? Well, let's try saving it into a variable and see if that works, right? So is this okay? And then I'll print the result. Oh, it was an extra. Yeah, so that seems to work. And so what we'll start to realize here, right? Actually, let's do this, okay? So I can save it into a Boolean variable. Can I use it as a conditional expression? Okay. Let's try that. So let's write an if statement, and we'll say, okay, so now I have an if statement, and it doesn't like something about this. Oh yeah, I got rid of result. Okay. And so now let's change this to have a 3, and now I see that the if statement is entered. So it looks like I can also use a call to a function as both the right side of a Boolean assignment when I have a variable on the left side, or even in a conditional expression. That's because in this case, the result of Boolean, the return value of my function is a Boolean. If I change this to int, then Java is going to be upset about it, even if I fix the return types, right? Now what I could do is I could say if this is equal to 1, then this would work fine, because now I've converted the result of calling the function, which is an int, into a conditional by combining it, by using it in a conditional expression with an equality operator and the value 1. So I can do that, and now I can do the same thing. If I wanted to, I could say count is equal to 8 plus search array example 2. Okay, and that would also work, right? So here I can use search array anywhere that I would need an int. So in a mathematical expression, in a conditional expression where I'm using equality to test against another int value. So there's somehow a call to this function is transformed by Java into a value of whatever type the function returns, right? So if it's a Boolean value, I can use it in a conditional expression directly, in a conditional statement directly. If it's an int, I can use it as part of a mathematical expression, or I can use it, in this type of conditional expression with an equality check. So this is the basics of how functions work. This is, I will admit, just as a little bit of a meta lesson, I thought long and hard about rolling this particular topic out today. I was thinking, maybe next week we'll do it after Labor Day. And I decided to do it now. And, one of the reasons is it's super important. This is kind of like, up until we talk about functions, it's actually kind of really hard to have you guys do certain types of problems. You are going to get a lot of practice with this topic. So if it doesn't make sense, if it's a little bit confusing to you right now, don't worry. Today's homework is quite straightforward. Ask on the help site if you need it, or on the forum. Tomorrow's homework will be a little bit trickier, but from this point on, for kind of like the next week and a half, we're going to write functions. Actually, I would say maybe for the next 2 weeks, right? We're basically going to write functions. Every homework problem is going to be write this function, right? Write this function, write this function, write this function, have it do this thing, have it do that thing. We'll start talking about other types of data next week that we can work with, including text data, which is really cool, gives us some new problems to solve. But from now on, we're going to write functions. As we go, we'll point out how they work, we'll add some, complexity here and there. But at this point, once you guys have seen function definitions and return statements, we have a lot of the basic building blocks that we need, and the structural components, right? Functions, right? That we need to kind of do a lot of cool things. And so that's why we pushed this out there today, a little bit, early maybe, and on the heels of yesterday. Maybe it feels like there's been a lot of new stuff that's been dropped on you pretty quickly. But I promise that tomorrow we're going to kind of slow down, integrate, kind of consolidate our knowledge, practice, get some chance practicing with error messages, and then we'll also talk a little bit about sort of how you stay sane as a computer scientist working with computers, which are can be incredibly frustrating. Anyway, don't get me started. The other day, and I've never had anything like this happen to me before. This is just clearly an aside. My wife has a computer that I help set up for her that she uses to do some of her work on, and it's a what I thought was kind of like a nice Mac desktop for her to use. And she tried to log in the other day, and it was like not accepting her password. So I thought, okay, that's weird. So I went up to check it out, and it turned out that her user account had just vanished, just gone, like just floated away on the breeze. Happily, all of her files were there, and all of the data was still there, but somehow the computer, and I'm sure it had a reason for doing this, right? That's the thing. It's like the computers just don't do stuff randomly, right? There is something wrong, or something went wrong, clearly, because again, I've never seen anything like this before. It was pretty easy to fix, but I told her, this doesn't fill me with confidence about this machine, right? Because that's not something that should happen, right? Apple, shouldn't just suddenly delete one of the accounts on the machine for no reason. So anyway, computers can be incredibly stressful and frustrating. I got pretty angry when I was fixing this problem, mainly because it's one of those things where I don't understand why it happened. And so, it could happen again tomorrow. It could happen again in a week. Maybe the next time, all the data on there is going to be gone. So it just, I don't know, fills me with fear. But anyway, there are some great coping strategies for, keeping your head as you go about working with computers and on computer type problems. And we'll spend some time tomorrow talking about those. All right, I will hang out for a minute. How far in this semester do we get to building classes? Yeah, so that's coming. We'll get there. We have, roughly, it's a great question. So roughly speaking, I think of this class as divided into 3 parts. Part 1, or part 0 that we're in right now, imperative programming. So no objects, no classes, basic building blocks of, conditional expressions, working with variables, loops, functions, strings, which we'll get to next week, And then just, again, the chance to kind of integrate and consolidate that information and do some computational thinking. Then part one, the second part, objects and classes. So we do a big chunk on that, right? And that'll come up, again, in about 2 weeks. So we have a midterm. First midterm is on imperative programming. The second unit in the class is on object-oriented programming. And so we'll talk about how to design classes and all the kind of cool stuff that goes along with that, and instance methods and having classes maintain state and stuff like that. So we'll do that for about the second third of the class, and then the final third is the algorithms and data structures chunk. So there, what we really do is we kind of take everything that right? All the imperative programming stuff that we're doing now, all the object-oriented programming stuff that we do next, and we just let ourselves out to play. And we talk about trees as an example data structure. We'll talk about lists. We'll build some stuff together, some really neat things. We'll show you how to build. We'll basically show you how to build Java's or built-in array list, which is super fun. And we'll also talk about algorithm analysis. So we'll start to understand the basics of why does something take as long as it does? What should we expect when we run certain algorithms or work with certain data structures? And so that's kind of like the final third of the class. That part is, I find all of this to be tremendously fun, but that part is really fun because at that point, you all know enough to kind of start to actually really build some real things, right? I do stuff we do stuff in this class extremely successfully. When I talk to my colleagues, they're like, you guys did graphs one semester? I'm like, yeah, it was fun. We'll talk about recursion in that part of the class as well. It's a problem-solving technique that's a good fit for some of the data structures that we'll start to talk about. So yeah, that's kind of the trajectory, the overall trajectory of the class. It's a great question. I should put that up on the syllabus somewhere. This is usually something we talk about kind of in the first week, but I don't think I really gave as much of an overview. So yeah, first third, imperative programming, functions, strings, basic sort of algorithm design, computational thinking. Second third, objects, classes. Third, data structures, algorithms, algorithm analysis, just lots of fun. So yeah, that's how we go. Yeah. So second comment. Yeah. So let's actually look at this. One of the things that I didn't introduce yet in today's lesson is this idea of a function that doesn't return a value. And there are cases where you don't want a function to return a value. It's not tremendously useful because if you think about it, like when you give a function a task to do, you kind of want to know what happened, right? And so there are void functions, which are functions that don't return values. They're typically not very useful. If you go down into this lesson a little bit, I do talk about the fact, and this confuses people, right? So when we print something, that's not a return value. That doesn't indicate to the code that called the function what happened. Printing is really something that we do primarily as a diagnostic tool to help us, the humans that are watching the code execute, try to understand what happened, right? It's sort of a way of having the code talk to us. But that doesn't mean that the code that tried to use this function has any idea what happened. So with our search array function, and I know I just broke it, right? It should really return a Boolean. That's really what we want. We want to return a Boolean value. And as we design other functions together, we'll talk about what the right return value is for them. And then we'll also have to talk about some cases where it's not clear in certain corner cases what to actually return. So in this example, one case you might think about is an empty array, right? Does an empty array ever contain a value? Well, no. So that's kind of an obvious one, right? But we'll have some cases later where, like the maximum, right? So we'll do a problem where we look at the maximum and the minimum in an array. Well, if the array is empty, what's the maximum, right? There are cases we want to return a value, but we're not exactly sure how to return, what value to return under certain kind of weird cases. As soon as your array has one value, then the maximum is well defined. But an array that has 0 values really doesn't have a max. Happily, an array that has 0 values can still be searched, right? It just never contains anything, right? And you can imagine like what happens if I pass an empty array, and we can do that. Let's do this. Oh, it's mad at me because I'm using this as a dueling. Well, anyway, we don't have to run it. You know, what happens if I pass an empty array as the array to look through? Well, in that case, values.length is 0, right? It doesn't contain anything. I starts off as 0, but this conditional expression immediately evaluates to false. So I never enter the loop. And I drop here, I return false, and I'm done. So it does the right thing, actually, which is pretty nice, given an empty array. But like I said, there are some cases where empty arrays cause problems for us because we're not exactly sure what to do, right? You know, sum over an empty array is kind of a nice one because that's 0, right? The count over an empty array is 0. The number of elements it has is 0, right? But max and min are a little weirder, so we'll get there. Great question. All right, so I'm done for the day. I hope you guys enjoy the day. It looks like beautiful weather in Champaign, at least, if you're allowed to leave your room. Hope everybody is safe. Obviously, there is, you know, some scariness going on around us, and I hope you guys all are taking good care of yourselves. Just remember, you know, everybody right now has a fair amount of sort of exogenous, external stress and anxiety. So, you know, if you're getting a little more frustrated than usual, or if you're a little more upset than you might be normally, keep in mind what's going on around you and the fact that you might be trying to cope with that. So, all right, good luck. I will see you guys tomorrow.